Good pipelines start with good documentation. At Airbnb, they have this thing called the MIDAS process, which is how you build a solid gold pipeline that is going to stick around for a long time, that people understand, that people know how to debug, that people know how to improve. And it really allows pipelines to have a lot longer long-term value. And in this 2-hour course, we're going to be going over everything that Airbnb does to build these pipelines. I'm really excited for you to check out this course. And if you want to build more pipelines in the cloud, definitely check out the dataexpert.io Academy. You can get 20% off in the description below.
How many of you have experienced working with bad data? I think that this is probably one of the things that is a very common pain point with data workers is getting clean data and getting data like able to be good and everything. So what are we covering today? One is how to build high trust in the data sets that you build. Because without that trust, without that acknowledgement and that trust, like, are you really being data driven? If decisions aren't being made off of the data sets that you're creating, are you even having the impact that you're expecting to have? Like, who knows? I think that's a big thing that you want to think about as you're kind of going through this process today, is really think about trust and how trust can be built and how trust can be broken. Because both sides matter here, and we're going to be covering kind of both sides as well in this presentation today. Also, how to build good data documentation. The entire lab today is on how to build a spec, and that's also what y'all's homework is this week, is going to be how can you build a good data spec. That is very important. And a lot of times, like, if you actually go through the entire spec process, you will find that you create way better data that answers way better questions than if you just immediately start writing SQL. Like, you're gonna have a way better time if you actually do this upfront thing. And besides that, like, it will increase the quality of your pipeline, but then your pipeline is documented. Then people, non-technical people or other technical people, like other engineers or anyone else who needs to like look at your pipeline and look at the data, they can learn about everything that you're creating way quicker than being like, oh yeah, here's my Airflow pipeline, go read a bunch of Python code and, scratch your eyes out, like freaking, because a lot of times that's currently what most data engineers do. They just like immediately go into Airflow and SQL, and they don't even think about the spec because there's a lot of pressure to like create pipelines and to give data. There's that trope of like, you have the data scientist who's like, hey, can you just quickly pull this data for me? And then, data engineers like jump out the window, or they like throw a chair or whatever, right? Because that pressure is just obnoxious. And the last thing we're going to talk about is data quality checks. So, in the first 2 weeks, we talked a lot about facts. We talked a lot about dimensions. Those are great. Data quality checks are also going to be a big part of this. We're going to go into a lot more detail on data quality checks and automated data quality checks next class on Wednesday. But today we're going to go into a lot more detail, especially on like the more theoretical side about data quality checks. So yeah, let's get into this lecture. Okay, so what does data quality even mean? That was one of the things I alluded to in the last couple slides. So one of the most important things for data quality, and it's underrated, but also difficult, is discoverability. So what that means is like, if someone's trying to make a decision and they want to know like, oh, does this data exist? It's easy to get that data and easy to find that data if it exists. And so like a part of this is like a cataloging problem of like showing all the data that your company has, which is like, that's not as much of a data engineering problem as more of like a data infrastructure problem, but they are related. They are definitely related. And we're going to go a lot more deep into discoverability in a couple slides. You also have misunderstood and incomplete definitions of data quality. So like, I just want to give a quick example. So I don't know if y'all like remember Zillow, and they thought that they had this like perfect machine learning model that was going to like predict the housing market and predict everything that was going to happen. And then they bought a bunch of real estate, and then they lost like $100 million or something like that. They lost some weird sum of money because they were like so confident in the data that they were creating. But the thing is that their data wasn't high quality enough because they didn't think about the gaps of like, oh, what other things could this model be missing? Like, what other data points might be very important to also include? And sometimes you get, sometimes even if you have complete data, you get other things, right? Like, if y'all ever heard of like black swan events, which is just like a crazy event that happens that is very hard to predict. Like a good example there is like the COVID-19 pandemic, like being able to predict like when that was going to happen. That kind of black swan event is an example of some things that are like a little bit trickier for machine learning models and data to predict. Sometimes they can get a decent idea, but when they're like rare events, like good luck. So obviously then the third bullet point here is like kind of the standard one of like, okay, for columns that are supposed to not be null, they're never null, and especially for dimension tables, there's no duplicates. So that's great. Let's talk about the last three here. These are trickier. So there is business value being derived from the data. This is one that can be tricky sometimes, because what does that mean? What does business value mean? So usually that means money in some regard. Sometimes it might be a couple degrees removed from money. Like, for example, say you're looking at, say you're building a pipeline that measures user growth. Say, like, we'll just use Facebook since I work there. So if someone signs up for Facebook, like, how much money does Facebook get when someone signs up for Facebook? They get nothing, right? And so, like, actually tracking how many people sign up, they don't get money directly. That's like a growth, like signups is a leading indicator of money, because it's like the only way that they actually make money is if people sign up and then they stay and they stay in the feed and then they start consuming ads. Because if they start consuming ads, that's when you're going to get a lot more money, right? And some things can be even further removed, right? So think about it this way. Like if for Facebook, say they went and spent money on Google, and they spent money on Google ads to get more people to go to Facebook. Because then it's like, okay, just because they clicked on the Google ad doesn't mean they're going to sign up. And just because they signed up doesn't mean that they're going to watch stuff in the feed. So that like the number of clicks from Google is even further removed from actually making money. But my whole point here is, generally speaking, you can, like, every single data pipeline that you write is either going to generate more money. There's going to be some way that it generates more money, or like has like an obvious way that it is connected to revenue. Or it could be on the other side. It could be cost savings, where like you might be making a pipeline that measures how much spend is happening on AWS so that you quit giving Jeff Bezos billions of dollars. That's one of our goals as data engineers, is to make Jeff Bezos less rich. So that's the idea. Business value usually is revenue. There is one exception here I want to talk about with business value, is if you're creating data sets that provide strategic value. So say you're creating some big data set that is used for some big executive decision, and then it's just to inform that decision, and that might not be money in like a clear, direct path like the other data pipelines that you write are. But those pipelines are also kind of rare. I think I've written like one or two of those in my whole career. So generally speaking, the pipelines that you write are very closely linked to either revenue or cost. Okay, well, what about these last two? Data is easy to use. So this is an interesting one, because I spent the last 2 weeks teaching y'all how to make data a little bit harder to use by using arrays and structs and complex data types, and showing analysts like, hey, you should, use cross-join unnest, or, kind of blow up the data, or if you can like analyze it with these array functions. And like, you're going to have to be a little bit more technical to look at this data, right? And so obviously this is something that is a continuum, and it depends on your data consumer on like whether the data is easy to use or not. But generally speaking, what I mean by data is easy to use is the column names are obvious. The column names make sense. The column names are clearly distinguished. Like a very common thing that happens at Airbnb is you have dimension columns and metric columns, and the dimension columns start with dim and the metric columns start with M underscore. And that is a very common naming convention. I would hope that naming convention gets more adopted like across industry, but some people are different. They like to use other things, and some people are like, oh, that's like excessive. Just put dim in the table name and then you're good to go. Like there's a lot of debate on like the way to actually name your columns. We're going to cover that in another slide. And the last thing here is the data arrives in a timely manner. Like a big common thing between analytics and data engineering is when there's a data delay. Analytics is like, data engineering, like, where's the data? What's going on? And so especially this back and forth happens a lot when there isn't an agreed upon refresh interval. So, for example, when I worked at Airbnb, I worked on unit economics. And when I first was working there, the unit economics pipeline was like so bogged down and slow. And like the refresh interval was 3 days. And so like the only time what it meant was like if analytics came to me and they're like, hey, the data's 2 days late, my for me the response for that is do nothing, right? Just wait. And then if it's more than 3 days late, that's when I'll actually troubleshoot. So coming up with agreed upon arrival times for data is a very powerful thing that can help your analytics teams kind of be more streamlined. And it makes it so data engineers get less requests as well, because then the analytics team can be like, oh, it's delayed, but it's not delayed enough that I need to like ask someone about it. It's like not quite at it's not problematic yet. So those are a lot of the pieces of like what data quality means. There, like obviously there's more to it than that, but that's kind of the idea. So data quality, like in a very short way to think about it, is data trust plus data impact. So it's you have people that believe in the data and believe that it's correct. And then on the other side, you have the data is correct and changing the business. And if you have those two properties of your data sets, you're going to have a good time. That's like, if you can consistently create data sets that have those two properties, you're going to get promoted very quickly. That's like it's more difficult to do than you would think. And that's one of the reasons why we're here in this lab today, is to talk about how to do this, because this is not an easy process to consistently deliver high quality data every time. So yeah, let's dig a little bit deeper into this. How do you build high trust in data sets? So this is coming from the angle of before it's in production, before you've created any pipeline. You really want to lean into empathy is a big thing. I think it's one of those things that data engineers, like generally speaking, don't do enough of. In this case, what I mean by that is you need to get all of your downstream stakeholders together and be like, I love these conversations. They're like some of my favorite conversations is like you get your downstream stakeholders together and you're like, if cost and time wasn't an objection, what data would you want? And like really have them like shoot for the sky for two reasons. One is it gives you a lot more clarity on like all the problems that they're trying to solve and being able to get more bigger picture kind of things. And it can also give you ideas of like what to do in a year or what to do in 6 months. And as you progress in your career in data, you're going to be wanting to think about those things, especially like if you want to go from senior to staff data engineer, your goal is to determine what to work on next. That is like one of the most important things. So this exercise in empathy can be very important in determining not just what to work on today, but to what to work on in 3 months, in 6 months, in a year, and like really starting to build those like long-term roadmaps of like what does data excellence look like. So yeah, those conversations are great. Also a spec, and this spec should be reviewed. The spec should be reviewed by a couple people. One is the spec should be reviewed by another data expert. Like at Airbnb, how it worked was every spec that was created had to be reviewed by at least another staff data engineer. So that was a requirement. And so if I wrote a spec, I couldn't review my own spec. I'd have to have another staff engineer review my spec. And so then that was just like a hard requirement. But you also needed the spec to be reviewed by the stakeholders. So both like a technical review by an experienced engineer and a review by the downstream stakeholders to make sure that you're covering most of the requirements. So obviously, that's great. Another big important piece of this is to clarify the business impact, because I think that that's one of the things that people can kind of get caught up with a little bit is like, how do you have the right amount of business impact and the right way of kind of describing that stuff? And one of the things that's really good is if you can clarify the business impact, that's also something that is great for performance reviews. Because sometimes, like, depending on where you're at in the development cycle, you're not gonna, like, say you're doing a spec review and it's December and you're just starting the spec review, then you're not gonna get credit for if you think that you only get credit when you finish a pipeline. That's not true. If you can build a spec that looks very promising, that has a lot of really good business impact, and you can convey all of that within the year and say it's in like November, December, then that can count towards that year's performance review. And that can be a great way to also kind of squeeze in one last thing to get more value into your promotion packet so that you get most of the credit for that pipeline for the previous year, not the coming year. And that can be another great way to help you get promoted. So like that's a great thing to think about and why clarifying the business impact is powerful, because like you essentially can take credit for the impact before it's delivered. And that is like, I don't know, like I've found that to be so tasty and so satisfying in my career that I've just been like, thank you. I'm glad I found this and saw this. And because then it's like, then you just have to implement it, and then you still get credit on the other side as well. So, also another big thing here is like talking to your downstream stakeholders about current and future needs. So a lot of times, stakeholders are going to have like a burning question, like they're like, I need to know availability of Airbnbs in Brazil in July 2023 because there's a big event going on and da-da-da-da-da-da-da-da, right? It's like they have a very specific, narrow question that they're trying to answer right now. And don't build your pipelines to answer that narrow question. If you do, you're going to have a bad time because then they're going to come back to you and ask another narrow question, and you're going to build another pipeline that's almost the same pipeline, and then you're like, that's called me and my manager back at Netflix, we called that like bespoke hell, because like you just keep essentially you build a pipeline for every question that analytics has, which is like not the way to go, because you want to be thinking about what their current and future needs are so that you can build a data model that answers their questions today and the questions they have in 6 months, so that then you don't have to make another pipeline. You can just be like, yeah, the data's already there. And when that happens, when your analytics partners come back to you with another narrow question, and then you can just be like, the data's already there, they will be like, wow, like that is one of those things that really gets you a lot of kudos, because they're like, wow, like I don't have to pull the data. Wow, I don't have to transform the data. I just have to do another query and I'm good to go. So that's why we spent, a lot of hours together working on data modeling, right? You listened to me talk for 12 hours because getting the data model right is very important for building trust and really wowing your stakeholders. And this last bullet here is called follow the Airbnb MIDAS process. I will send you guys links for this as well. We're going to go over the Airbnb MIDAS process in this presentation today. Also know that like my perspective on the Airbnb MIDAS process is that it's like most companies, they lean too little into quality. And I feel like the Airbnb MIDAS process almost goes too far the other way, where it's almost like too onerous. But we're going to go over it and even if you don't follow all of, I think it's like an 8-step process. It's a lot. Like, and so even if you don't follow all 8 steps, if you follow a couple of them, you will see a dramatic improvement in your data quality pipelines. So, or in the data quality of your pipelines. So don't think that I'm like saying you have to do everything that Airbnb does, because like most likely like you're at a company that might not have that many data engineers, and so they like it's not as possible. So yeah, let's dive into it. Oh yeah, 9. Wow, there's 9 steps. So let's I just want to go over each of these steps on like how Airbnb builds a very high quality pipeline and what it does with MIDAS pipelines. So MIDAS, I don't know if y'all know, he's like that's like a legend for like a golden touch kind of person. And King Midas, whatever he touched turned to gold. And so that's kind of the idea here. The MIDAS process is how to create golden data sets that are very valuable and they keep giving value. So the very first step of the MIDAS process at Airbnb is to make a spec. You make a spec, which is like, this is the pipeline I'm going to build, and this is how we're going to build it. And then step 2, right, is that technical review I was talking about and the stakeholder review. So spec review is you have to get a technical review from like a data architect, and then also a stakeholder review to make sure it covers their needs. Then you do a build and backfill of your pipeline. So you actually go and write all the Spark code and the Airflow code, and then you actually create the backfill code for your pipeline. Keeping in mind here, when you backfill, you're not backfilling like all of history at first. You backfill like 1 month. So then the analyst who you're working with will then start working on step 4, which is the SQL validation, which is where they essentially go through all the data that you created, like that 1 month of data that you created, and just like dig super deep and try to make sure that there's not any weirdness or oddities in the data. And it's crazy because I built like 8 or 9 of these pipelines when I was at Airbnb. And like every time I like finished my backfill pipeline, I'm like, this is rock solid. I will never have to do it again. Like I know I got it perfect the first time. And like I like every single time, like without fail, there was always bugs. And that's why you only backfill a month, because if you backfill more than a month, then it's like, and then they find a bug and you have to backfill it all again. Like that's just painful. So then you do SQL validation. And keep in mind, SQL validation needs to happen by someone who isn't you, right? That needs to be usually an analytics partner, an analyst, or like an analytics engineer, someone who isn't you. Because if you build the pipeline, your ability to check the quality of the pipeline is impaired because of the fact that you built it. It's kind of like how, people are very unwilling to admit that their children are ugly, even though we know for sure that some people have ugly children. Like, and you can just, but like, if it's not your kid, like it's a lot easier to call the baby ugly. So it's a solid way to kind of go about things, right? So then after the SQL validation, then you have the Minerva validation. Minerva validation is where you're looking at the metrics. So Minerva is an open source metric repository container thing that Airbnb uses to hold all their business metrics. And they validate all the new Minerva metrics. And this is done by like the same person, usually the same person who does the validation, they do the Minerva review or the Minerva validation. Then you have 6, which is where the data architect comes back. So I would do these reviews as well, where after they did all of this stuff, I would then go over their code and their data. So in this case, for the data review, I would just make sure that there's not any weird like modeling problems, because a lot of times in the spec review, you're not going to catch everything as an architect. And so I just review in the data review a final thing of like, this column's weird, or like, why is this missing, or whatever. And so that's the data review. And then the code review is where I go through the Spark code. And a lot of times with Spark code, the big thing is looking to see if they have tests. So they need to write unit tests and integration tests for their Spark code. And this is something, if you're in the combined track, which I think about half of you are in the combined track, we're going to literally be going over how to do that tomorrow, on how to do unit tests and integration tests on your Spark code, and like end-to-end tests on your Spark code. That will be a nice, fun little project to work on tomorrow for you in the combined track. Then after that, you migrate the metrics. That's what the Minerva migration is. Then you have one more review by like a data scientist, like a staff data scientist. And he's like, okay, these new metrics look good. And then you finally say, we created the data set. And that's when you launch the PSA. And that's the 9th step. So I'm sure some of y'all are like, damn, that's like a lot of steps. Like, because a lot of times, like, like most companies, like when you're working, I know, like especially like when I worked at Facebook, how it worked was there was step 3 and step 4, and like that was it for the most part. Why all this upfront work though? Like, why are we doing this? Why are we writing all this documentation? Like, why can't we just write our data and give them the data and then they can go on their merry way? A couple reasons, and some of them are actually tricky for some engineers to understand sometimes. So if you get buy-in from a stakeholder before you build something, they're going to feel like they built it too because they gave you ideas, right? Like it's kind of like how if you are like, "Yo, like I want to get your opinion about this art piece." But it's before you build the art piece and you're like, "What should I put in this art piece?" And then someone's like, "You should put a dragon in that art piece." And then you put a dragon in the art piece and then you show them and then they're like, "That's my dragon. That dragon's freaking sick." Right? And then they love it more, right? Because they feel like it's theirs, like they were a part of the process, right? And that's a thing that analytics people really like because, and it's also good too because if you can make them feel like they're a part of the process and then it's missing stuff, like they're gonna blame you less and blame themselves more, which is good for you, I think. I mean, it depends. Like, the blame game is also kind of toxic, but generally speaking, that can take a little bit of pressure off of you because you're like, yo, like you were, I looped you in for every step of this process. Like, why do we have to backfill again? And what it can do as well is it can highlight to management like where communication problems are happening because sometimes as a data engineer it's not even on you. Sometimes like analytics partners are just absolutely ridiculous in what they're requesting and like how they're requesting it. And so that's where like if you can loop them in throughout the whole process and really it's kind of like going on a bunch of dates with your analytics partners because like and you know if you just go on one date with them and you're like okay we're building this pipeline and then you don't even know if you're going to communicate with them well and then like you it feels like after you like buy it's like and then it's like when you give them the pipeline it feels like it's like buying your second date a car. It's like and like you know I don't know that a lot of people would say that that's probably a little bit excessive to buy to give a girl a car on the second date. That's probably like a little bit too much, right? And so that's where you can kind of think about how building up these connections, having these conversations, what it does is it also surfaces like, hey, we're having communication problems. Hey, like this isn't working out well, right? And you can catch these communication problems before people are so damn invested where it's like you won't be like oh we had these communication problems but then I still wrote 1200 lines of SQL and then I just freaking ate all the pain. And that is like I've seen that happen many times in my career as a data engineer. And that's stuff like that is actually how a lot of data engineers get like meets most on their performance reviews because they didn't communicate well enough and then they didn't clarify things and then they just jumped right into coding and then it made it harder for them to undo things because they already had a lot of it built out. And so that is it's a beautiful thing. When this works, it feels very beautiful and it feels like wow, we are like in this process of solving all of these beautiful business problems. And like it can feel fun too. That's the part that I've found very interesting about this is like especially for me when I worked in pricing and availability at Airbnb and I was doing these like stakeholder sessions of just like oh what do people want, like how do we want to change things, how do we want to implement things, and like actually really talking to stakeholders like whew, good stuff. That's that good shit, dude. Okay, and so anyways obviously I said they feel like they have the skin in the game. They're a partial owner. It's like they have stock in your pipeline, so they want you to win as well, as opposed to like building something in a corner. And then obviously there's a thing in all caps here, like you want to do this upfront work because backfilling is painful. Like I feel like backfilling is like the B word for freaking data engineers, and so like don't don't like worry about that too much. Like if you are doing all this upfront work, a lot of times, even if you do all this upfront work, you might still have to backfill twice. I mean, that's generally how it works for me. But like, if you don't do this upfront work, you might end up backfilling like multiple times, like 3 or 4 times or something like that. And like, that is getting a little bit excessive. That's also giving Jeff Bezos a lot of money. That's also just like, because data IO is one of the most expensive costs when generating data. And so like, if you're backfilling a lot of history, like you're going to have a hard time. So yeah, let's go to the next slide here. Okay. So obviously, like not every single pipeline is worthy of this 9-step process. right? That should be clear. So there's going to be two big things here. I think one of them is, okay, are there any important business decisions made by this pipeline? And like, important is obviously like relative, but generally speaking, if it's not, and it's just more of like maybe exploratory, or maybe there might be a trend here, or like, because sometimes you do have that space to like kind of look at things in a more exploratory way in analytics. And those pipelines, a lot of those like exploratory like prototype pipelines, they have value, but they don't have value in terms of like they need to stick around for years and years and years and give people value every day. And so those kind of pipelines, you probably don't need to do this 9-step process, and that would probably be a massive and ridiculous waste of time. But another big thing is like, if the data is going to change a lot, like if you are going through a lot of churn or process stuff, like then it might not be worth it to do it now, but like wait until that churn has like kind of happened. I know that that was a big thing that was happening for me, like in unit economics. Like payments was going through this big like refactor, and I was like, y'all need to like give me a Midas pipeline. And they were like, no, we're not going to give you a pipeline, because of the fact that like if we did, we would have to just build it and then deprecate it in 3 months, because everything's going to be different soon. So like that's another thing to think about, is like some of this stuff, like this heavy process is really for multi-year master data that is going to keep giving value over and over and over again, and it won't be subject to very disruptive change. Or if it is subject to disruptive change, it happens on like a couple year basis, right? It's not going to happen soon. It might happen in a year or two. So that's a big thing to think about when you're going through these processes, because just because you're doing a heavy quality process doesn't mean you're delivering value. And sometimes not doing the heavy process will deliver more value. That's like a big thing to remember here, is that there is kind of a gradient here. Like it goes like you can go as far into quality as you want, or as little into quality as you want, and like they have their pros and cons, right? It's not like always do the process or never do the process. There's a couple big things that make a good spec. One is the description of the pipeline. Like, why are we building this? Like, what is the purpose of this pipeline? You also have things like flow diagrams, like how things kind of position, and like how data goes from like the raw data to the fact and dimension data to the metrics. Then you have schema. Schema is going to be like your DDL statements and your create table statements, and then column comments to maybe talk about any oddities in any column comments. And you also want the quality checks, and like, because you want the quality guarantees in the pipeline, because that stuff that can be very good to add as well. Metric definitions, also important. Like what metrics are you trying to even measure? And the last one is example queries, which is like, especially if you have more of that like struct and array format stuff from week 1 and 2. Having some example queries to show people can be very powerful, because then they might come and ask you questions of like, how do I query this? And then you already have a good example for them. So that's kind of the idea behind what makes a good spec. Okay, let's just kind of go over this, like what's in a good flow diagram. So here's a good example of like one that might be in a MIDAS spec when you're creating your data. So you see how we have our input data sets here. We have dim countries, dim users, and raw activity. And so these three come together, and then they create this fact table called fact activity. And that is going to be our, this is like the master data. Generally speaking, I would say that this orange table here would be what's called the master data. That is going to be what most people query. And then you have, you can also create like an aggregate table, which you can think of as just grouping this table and moving it down. And then you can aggregate the aggregate table and create the fine grain metrics. And this will give you like some ratio metrics. These are per user. Obviously, you can have other metrics that are like totals and stuff like that as well. But generally speaking, like these diagrams, I like to use Lucidchart for this. That's what I use this for. You can get like a free trial for Lucidchart, and you can build this for free. Google Drawing's okay, but I don't know. I feel like every time I use Google Drawing, I always feel like I'm like a kindergartner who's like writing my freaking flow diagrams with crayons, and like I don't know. It doesn't feel good to me. It doesn't feel good to me. So I'm more of a lucid chart kind of guy. But that's, at Lucid Chart, you should sponsor me. Okay, let's go to the next slide. We talked about schema. So your table names should look good. Generally speaking, your table name should have either fact, dim, SCD, or ag in the name to illustrate what type of table it is. So it's either a fact table, a daily dimension table, an SCD dimension table, or an aggregate table. And pretty much every single table at Airbnb freaking had one of these in the name. Like that was kind of like a requirement, and it made it so it was like a lot more obvious like what kind of table this is going to be. And then if you have people who just have even a basic understanding of data modeling, they can understand like, okay, this table's for events, this table is for dimensions, right? And you can get all sorts, you like just from that in the name, you get a lot of information. So obviously for your schemas, you also are going to need a lot of comments for your columns. Like make sure that every column has a comment. And these comments should follow the naming convention that your company chooses. And if that doesn't exist, if you're at a company that doesn't have naming conventions, then that's a great place to freaking get a lot of impact. And that's something that you should be yelling at people about, where it's like, why do we not have consistent naming conventions? Why are we doing things this way? Like, obviously, if everyone's going to do their thing their own way, like, people are going to have a harder time understanding this data. And so, like, you just got to be very clear with people. And this can be a massive way to get a lot of impact. And there's a lot of companies that aren't doing this, because I mean, a lot of companies aren't big tech and they're not like so far advanced in their data practices that they even have this yet. So that can be another great place to go. But the key thing here is follow the naming conventions at your company or build them if they don't exist. Comment every column. Every table name should have fact, dim, SCD, or ag in the name. Those four, if you do those four for your schemas, you're going to be very far ahead of a lot of different people. So that's a good way to build good tables that have good names and good columns. Quality checks. We're almost here, and then we're going to take a break here in like 5-10 minutes. Been talking a lot. So quality checks come in three flavors. You have the basic checks. Basic checks are really easy. Basic checks, generally speaking, like every pipeline should have these basic checks all the time, because if they didn't have these basic checks, like what are we doing? They're so cheap. They're like free essentially. So like, and they also help a lot. Oh, I forgot to add one. There's one more basic check, which is like, is there data? Like there's actually data, right? There's the not empty check. And then you have not null for any column that's not supposed to be null. Like it's never null, no duplicates. Make sure that's the case. And then enums, right? We've talked a lot about enums, and make sure all the enums are a valid value, because in the data lake environment, like it's different from Postgres. Postgres is going to enforce it for you, and you don't have to worry about enum values. But if you're in the data lake environment, like in Spark or in Presto, like it's a lot more flexible. So you need to test these values yourself in your data quality checks. Then you have like intermediate checks. Most of this is like row over or week over week row counts and everything like that. So in this case, like when you look at like week over week row counts, you want to do week over week and not day over day, because of the fact that like Saturday versus Friday is going to be weird, because a lot of times companies and things have different behaviors on Saturday than they do on Friday. But if you compare Saturday to last Saturday, that's going to be a better consistent trend. There still could be other seasonality things that happen on a longer term cadence, like for example, holidays, right? Where like Christmas, these intermediate checks, like they fail on Christmas all the time. Like it's annoying how often they fail on Christmas because of like the seasonality. But companies are getting more mature, and they're actually getting more like machine learning and stuff like that involved as well, so that then you can do seasonality adjusted row counts, so that then you can look at both week over week, but you can also look at it in context with like last year or the year before, so that you can get like a longer term seasonality context, so that like your data quality checks don't false positive more than they should. And that's how you get into those advanced checks, where you like bring in the heavy guns, you bring in the machine learning, you bring in all that stuff. And that can oftentimes make your quality checks higher signal and less noise. and that can be very powerful, but like bringing these in can also be kind of expensive depending on the company that you're working for. So as your data infrastructure improves, generally speaking, these advanced checks become very easy to add. I noticed that like at Airbnb, it was like seasonality adjusted row count was like, it was like a YAML configuration, one line of code, done. So how do you pick quality checks? So dimension and fact tables generally require different quality checks. We'll go over that real quick here. So dimension tables, generally speaking, they either grow every day or they're flat. Especially if you're doing like cumulative table design, then like they should be growing or flat every day. So a very common check for dimension tables is table is growing, which is like, is there more rows today than yesterday? And like it should almost always be like an up and to the right trend. That's like but like at the same time, you don't want them to grow too sharply, which is similar to that threads example that Stephanie just brought up, is like, because like if you have like week over week, say there was like 100% more users, and it's like Facebook's like, we didn't get 2 billion signups this week. Like, no way, right? And so there's going to be a percent that is reasonable for your users depending on like the volatility of your data set. And then you also like, you want to make sure your complex relationships are also checked. So in that case, like for example, on Facebook, there is like, say you're working in the friending environment. One of the hard limits in friending is you can only have 5,000 friends on Facebook. And so like, you want to check that. Make sure that there's no one more than 5,000 friends. Like, make sure that that's like enforced in the data, right? And other things too, like say I have progressive car insurance, and it's like, if I have an active policy, there should be a car in my policy as well, not just me, right? Because Progressive doesn't do like health insurance, right? They only do like car insurance. So you can think of like all the different like connections of your entities, and sometimes they have to exist. And like if they have to exist, that should be a check in your data pipeline. So that's the dimensional data quality checks. Dimension data quality checks are usually simpler, and they don't false positive as much. Then you have fact quality checks. So facts usually have like the seasonality problem. That's where like if you have row counts, you don't want to do day over day because the whole Saturday, Friday problem. Always do week over week. Again, this can have a problem where it's affected by holidays. Facts can grow and shrink based on user behavior. So in that case, the table is growing check from the previous slide is not a good check. Facts are more prone to duplicates because duplicates are a lot more likely to happen in logs than they are in production databases. So the duplicate check is very important in fact data. More prone to nulls and other row level quality issues, obviously, that stuff. Like, because it's logs, and logs a lot of the time aren't critical for the app to run. And so that can be where software engineers can get more sloppy when they're working on logs than when they're working on like production database snapshots. So that's also true. And then obviously they can have a foreign key. It's like you can have references like, it's like I received this notification from Facebook. You got to make sure that user ID is real, and and this is cool as well. You can also do other enforcement. Like, what if you have deactivated users, right? So it's like, we want to make sure that there's no deactivated users on Facebook who are receiving notifications, because that is also like a bug. It's like, it's a different bug, right? It's not really a data quality bug, but it can catch infrastructure bugs that are happening like in other places in the app. So you can also catch things like that, where these data quality things actually caught some like cybersecurity problems at Facebook a couple times, and they were the first place to alert that like, hey, there's an issue here. Some people are getting hacked. Something is happening here. And so know that like these data quality things aren't just to build trust in you, but they can also help the business in kind of ways that you wouldn't expect, especially if you do a good job here. Okay. Last thing I want to talk about is like in the dupes. When I was talking about dupes in for fact data, don't use count distinct. Like when you're in Presto, just don't use it. Like, it's terrible. Like, it's so terrible. And like a lot of times, especially if you have high volume fact data, Presto will just die because count distinct in Presto is terrible. If you use a prox count distinct, that's going to be better, and that's going to capture 99.9% of the data. There could still be a chance that there's like one duplicate, like in some like far away land, but this is going to capture 99.9% of the time, and it will make your pipeline run faster. So if you're doing your checks in Presto, use a prox count distinct and not count distinct. It's just like a random little tip.
Congrats on getting to the end of the spec building lecture. There's a lot of steps in the MIDAS process, right? If you're taking this class for credit, make sure to switch over to the other tabs so that you can get the time tracking that you need for the lab. I'm excited for you to check this out.
So in this case, I already started building out something here. Like a lot of times you want to start out with like some sort of nice title. I'm calling this the Exactly Inc. user growth pipeline. And then what, we talk about like we want to measure website traffic and user growth, and it's kind of the idea. That's why it's called the user growth pipeline. And then what we're going to be doing is talking about, okay, and they say the goal of this pipeline is to answer the following questions. So this right here, like you'll see as if a data analyst comes to this spec and then they're like, oh, I need to know about this, or oh, I need to know about this metric, or I need to know about this. It's great. You can definitely like get a lot of information just from the description of a pipeline. And obviously, we have a couple more things we want to kind of go over here. Hopefully, we have time here. I think we should. So when we're going over like business metrics, one of the things that I think is important is this is going to be like a table. So let's go ahead and insert a table here. And I think there's going to probably be it's going to be probably like a 3x4 table here. So in this case, we have like metric name. And then in this case, we have, I like to call this like is guardrail. I'll explain what that means here in a second. And then we will, and then is like, this one is like, is ratio or something like that. Or like, no, it was, my bad. It's like this. So you take is guardrail, move him over here. And then this is like definition. So in this case, we want to come up with some metric names that are coming from some of these questions, right? So one of the things you can think about is, okay, what percent of traffic is converting to signing up? So I think that's a good one. So we could say like sign up conversion rate. That's probably a good metric. I like to bold the metric names. So the definition here, right, is going to be like count signups divided by count website hits, something like that. And obviously this definition is like kind of sloppy. It would be like as you kind of define more of the schemas further down the line, that is going to be one of your things. So what do I mean by is guardrail? So a guardrail metric is a metric that signifies a problem to the business that is really bad. So like if you have a metric that is a guardrail metric, what that means is it's protecting the business or like the measurement there is trying to protect the business, like especially in the case of like an A/B test. So imagine if you launched an A/B test and the A/B test essentially says, oh, this A/B test is very negative on this metric. And the metric is, I don't know, maybe it's something like profitability or it's like growth or some other kind of really important metric. And like essentially what the guardrail metric will say is like, don't launch that test. Don't roll that out to production. That means that and that test shouldn't run at all, right? Whereas a non-guardrail metric might go down, but that's like more of, it's not like whether that's good or bad for the business can be, it's less clear. And so that's where you can have other metrics that are going to be like not guardrail metrics. I think sign up conversion in this case is a guardrail metric, right? So what about other ones here that like we can think about? Okay, I like this one too. What percentage of signups convert to paying customers? So I like that one. This is going to be like purchase conversion rate. And in this case, oh yeah, we can make this like a little bit like that. So in this case, it's going to be count purchases divided by count signups. That's going to give us that. This one I think is also a guardrail for a different reason. So I think this first one is a guardrail because it indicates that there's a problem with the landing page if this number goes down. And then this one is a guardrail because it indicates that there's a problem with the checkout page if this number goes down. Now let's create one more metric here that maybe isn't a guardrail metric. That's maybe like one of these, like where are these people coming from? So I think in this case, like we can say it's going to be like traffic breakdown, or we'll say traffic breakdown, call it like that maybe. And then in this case, we're going to have like count website hits group by referrer. I'll explain what referrer here is in just a second. That's essentially like, think of like referrer as like if I am on LinkedIn and then I click on a link on LinkedIn and it goes to exactly.com, then LinkedIn is the referrer. It's like where you came from. So that's kind of the idea here would be like, okay, we want a breakdown of like all of the websites, but grouped by referrer, right? So that'd be the kind of like, it's almost like that's kind of the idea here. Obviously, like this metric, like you could have this metric be broken down into like traffic, LinkedIn percent, traffic, Twitter percent, and you can kind of like pivot it out. And I mean, and honestly, that's probably like if I wasn't trying to build this spec in 40 minutes, I would do it that way because then that's just one number. Whereas this is like dozens of numbers, right? Because the number of websites that point to my website is pretty high. So in this case, I want to say this is no because a couple of reasons. Like one is an A/B test is not going to impact whether or not my traffic comes from LinkedIn or Twitter or wherever. Like that's all on me and how I change my social media channels. So this is not a guardrail metric because of the fact that like whether whether I do an A/B test on my website should have no bearing on where the traffic comes from. So this is kind of the idea behind like when you're coming up with business metrics and how they could be useful in your kind of diagrams, right? So we got a couple more pieces here. Obviously, there's a lot more different business metrics that you could come up with. We're gonna stop and put it there, but we could also come up with some more later on. But let's put an enter here. I don't like that like the flow diagram be on like 2 pages like that. But so in this case, let's go to Lucidchart and kind of go over how we can build a flow diagram of this. So okay. Can I just like copy this guy? Because this guy was already so good. Okay, great. We can just start with the one that I used for the presentation today. So let's go back to kind of the business requirements here. And you'll see it says, let's like kind of look for some things here that I think are important to call out. So you see this like, what is the geographical and device breakdown of that traffic? So what that means is we need to somehow figure out where the traffic is coming. So traffic, generally speaking, is how we measure that, like where it's coming is there's an extra step in that process there. And that's going to be what's called like IP enrichment, where you need to like take the IP address and then pump it to some website. And then it will tell you like, oh, this is a California IP, or this is a New York IP, or this is an India IP. So we need that. But we also have this device breakdown, which has its own thing, right? Where a lot of times you can have device identifiers or you can have user agents. So there's going to be another layer here, probably. There's probably 2 layers here. There's an IP enrichment layer and a device enrichment layer that we're going to need to include in our source data because it's not in the source data. Like with that being said, let me kind of just go over what's going on with that. So so if we go here and we say like, let me close that. So we say like select star from events. This table is like the rawest of the raw data. You see, yeah, like an event ID, and then you just have like this big old blob of JSON. It's kind of terrible. But this is essentially the data. that we're going to be working with, and this is the rawest data. So this is our source schema. But in the specs, generally speaking, you don't have to put the source schema in the spec, right? The source schemas do not matter. It's all about the data modeling that you're doing specifically, because people don't really care about like where the data came from. They kind of trust that you're going to do the right thing. But I'm just trying to give you an idea of like what's going on here. In here, right, we have that table, right? So in this case, it's just a logs table, and we're just going to call this, we'll call it log, or we're going to call this events. And one of the things that's different about this schema and another schema, right, is that we actually aren't going to be doing any joins with dimension tables, because my business is pretty new, so I don't have any like master data. But we have things in the middle here that we want to also include. So a lot of times those things can be modeled with like a square. I like squares here. So what we want to do here is pop this guy here, and then move this guy here, and move this guy here, and then like I kind of want to move all this like over, and then move him. Okay, just move all of it over. Move this guy up here, this guy up here, this guy up here. There we go. So now that's like a little bit better looking thing. I mean, some of this stuff is probably now too far over, but so this first one here is called like IP enrichment, and then this second one here is called user agent enrichment. And so we can kind of go over like what those things are doing, but those are mostly API calls to take the data that you have and then make it like more complete. What's going on? Sometimes Lucid chart, there we go. That's more like what we're looking for. So then we have our events that create our kind of, this will be our highest level table that you can think of. This is going to be like, if you go back into here, you see how we talk about what is the geographic and device breakdown of that traffic. So now we have that. That's going to be our first table. But this is going to give us both though, right? Because every event in that table, there's events for website traffic, there's events for sign up, there's an event for purchase. All of these are also in there. Those are all different types of events that are in this events table. So then what we have is we have a table here called, I would call this one maybe core, and we can call this fact website events, or like maybe, yeah, call it fact website events. I'm happy with that name. Let's make this a little bit smaller so it's like actually fits in the square. So this is one table that I think is really useful. There might be some interesting columns in this table that we want to consider, and that's what we're gonna kind of do next here. Like we're gonna, and this is gonna be another beautiful part of like kind of showing you how these kind of specs are generally generated, is they have like you kind of go back and forth between like the schema page and the flow page, and then kind of trying to understand what you're going after. So we have the flow diagram, but let's think about the schema here. So in this case, we have that table, right? We have core.fact website events. Let's make this a little bit smaller. And then a lot of times, like you want to like do a description here. Oh yeah, let's make this even smaller. Let's make this like 14 point. There we go. And then we want to talk about how why is this not bold? This should be, so usually the table names are bolded, and then you could say like this table is a list of all events for exactly.com and includes IP enrichment and user agent enrichment for country and device specific information. So you can kind of think of like, you can add a little like description, a little bit of flavor if you're gonna talk about the table that you're creating. And so then what you can do, right, is you can go ahead and we probably want to add like a table here. Usually this table is gonna be, you need 3 columns. I'm gonna put probably, we'll do 3 by 8. So in this case, you have, why is this so big? It'll go 14. So we have column name, then you have column type. Again, it's freaking massive. Column type, and then you have column comment. What? There we go. Column comment. So and then it's like, why does it keep doing that? Can I like just like, can we just like there? Okay, so in this case, we want to think about all of the possible comment or columns that we want to add in this table. And this is going to be like kind of a quick and dirty kind of fact data modeling exercise. So one of the things that I think is important here is the website events table may and may not have a user ID in it. So let's go ahead and add user ID first. And user ID is type big int. And this is, we want to talk about, okay, so why can it may or may not have a user ID? So if you're logged into the website and you like go look at a course and you click a button, that your user ID will be tied to that event. But if you're logged out and you're like just checking it out, like you won't have a user ID. You're like logged out. So generally speaking, so we can say this column is nullable for logged out events. This column indicates the user who made this, who generated this event. So yeah, this is still too big. Should be like 11. Okay. Then we can think about other ones. We have country, right? And country is going to be a string, and the country, the IP, the country associated with the IP address of this request. Then you have like device brand, things like that, string, the device brand associated with this request. Right. Some of these column comments are pretty whack because like because they are obvious, like because the column name is pretty self-explanatory. So this is where you want to be careful with some of these names. I would actually throw in dim here. I'll probably do dim device brand and dim country. And then you have another column here. I think you have action type. This is going to be a string. Is an enumerated list of actions that a user could take on this website. And then you might want to add here like sign up, watch video, like go to landing page, you know, etc. Like it's like an enumerated list, and like that's where we can explain to people that there is only a certain number of values here. And so that can be one. Then we like I think we have only like 3 more columns to kind of like bash out here. I think you have event timestamp. This is a timestamp. And this is the UTC timestamp for when this event occurred. Make sure to always log your timestamps in UTC. But this is a great example of why documentation matters even for timestamps, because when you have a timestamp, like is it London time, is it East Coast time, Pacific time, who knows, right? And so this is a great way to kind of cover your bases when you do have a timestamp, because you're like, yo, this is obviously a UTC timestamp because I'm labeling it as such. So then I think you have another column here. You have like other properties as a column. And I call this a map. This is going to be a map of string. And this is going to be any other valid properties that are part of this request. So this column is going to not be used as much. And then we have one more column here, DS. This is string. And this is the partition column for this table. So that's kind of the structure so far. I totally forgot host name. Let's go ahead and add that. Like, so we're gonna put like dim host name. Right. This is gonna be string. What is the host associated with this event? Exactly.com, Zach Wilson, .tech, etc. Right.
Thank you. That is totally right. That is yeah. That was one that was missing in this, right? See, and this is why you build a spec, right? Because now like we're working on this together, and like now we already caught something, and that's when you have two sets of eyes. So there's actually we have a logged out user ID, and this is going to be a big int, and this column is a hash of IP address and device information. So in that case, like essentially what we say is, and this is what they use for the primary key of this table, right? Since user ID is nullable, you're totally right. But like we can have both here so that we can see a link between the two. So in this case, the logged out user ID is never nullable because every network request has an IP address associated with it. So in this case, what we say is for every logged out user ID, and so it's like if a request comes from the same IP address at the same time, then we can consider that a duplicate if they're like at the exact same time. But obviously, event timestamp is like down to like nanoseconds potentially, right? So like the odds of that happening are pretty low. But so that's a good thing that you can, right? So especially when you're in this kind of logged out world where like you don't have anything to no ID that you can enforce like an entity on. A lot of times you have to create your own ID out of the data that you have available. And so a lot of times they use, I don't know if y'all have ever heard of a murmur 3. This is a murmur 3 hash, right? We'll use the murmur 3 hash, right? That's a cool hash, by the way. I like murmur 3. It's one of my favorite hashes. Um, so that's totally right. Thanks for that feedback on like how to do this table. So then we can probably add that in here. The unique identifier for this table is logged out user ID and event timestamp. So that can be useful for this kind of to understand stuff, right? So we have our schema, we have our logged out user ID, we have all this stuff. And so this is going to be one table in like all this thing, right? And so, but this table is like pretty much like we only need probably an aggregate table as well. And I think that that will give us like pretty much all of the schemas that we need. And so let's go back to this lucid chart here. And we have this ag here. We're going to call this core ag website events. We're going to essentially just call it the same name as kind of the other one. So then these, let me move these over a little bit. Okay. Why is this one like so funky? Okay, whatever. There. So ag website events is going to be one where we kind of add some more layering to it, right? Where we have in our kind of, let's go ahead and copy like a little bit of this table and go down here. And then in this case, we're going to say core.ag website events. This is like way too big. Make this like 15 and fold it. And then we can say this table is an aggregated view of all website events, right? So in this case, we actually probably won't have a user ID at this point because it's going to be aggregated up. It's probably going to be like maybe a daily aggregation or something like that. Because that's usually what metrics you want, like these comments and likes and all this stuff are going to be like daily aggregates. So I actually think that this is close. Let's just get some of these. So we have like sign up conversion rate, right? And then we have purchase conversion rate. There's like traffic breakdown. So this is probably pretty close. That this is probably where I'm feeling pretty satisfied with like taking a screenshot of this bad boy and throwing him into the actual doc here so we can kind of see how this will work. Let's go back down and finish this schema real quick, and then we're going to shift gears to the other pieces of this that are not included quite yet. So I think in this case, the first column here is going to be your kind of string, right, which is going to be your date. Like, but a lot of times there's actually, we're not going to put that first. That's usually the last column. Like the partition column is almost always the last column. So we'll start with, in this case, there's probably going to be action type, which is going to be a string. And this will be the enumerated action type.
And then we talked about that enumerated up here. So obviously we could copy this column comment down if we wanted to or not. And then in this case, we have probably country string, this dim country. This is dim action type as well. Move this one. This is dim. Okay, so country for the IP country. So we're gonna insert like a couple more rows here. So in this case, what we're looking for is there's gonna be an interesting column here that I think y'all are gonna think is kind of an interesting one that at least I like for aggregate tables. But so we have country and we have like dim device brand, right, which is a string device brand. Some of the column comments can be terrible like that, but it's like, what else do I put here? Like you might put like Android, iPhone, etc., or however you want to enumerate it out, right? And then in this case, we have maybe. So this is where like it gets a little bit tricky, or maybe we have event hour. I'm gonna put an integer here, and I'll explain why we're putting hour in here, and I think it will make more sense. So the hour this event took place in UTC. And then in here, we're going to say M total events. This is going to be a big int. This is the total number of events for this slice. And then we're going to have two more columns here, insert row below. Then in here, we're going to have aggregation level. And I'll explain how this works. And this is going to be this will be a string. And then we have DS, which is a string, which is the date partition for this table. And then aggregation level this is how this ag table is grouped. And then we can say values include, so in this case we have a dim action type. Then like there might be dim country, dim action type. So like you can put like a bunch of different aggregations in here, like and maybe you have overall. Overall is an aggregation level. And so like, and then there's probably one more with event hour, right? And so you can have like all of these different aggregation levels in one table, in one aggregate table. So then you can like all of that, you don't have to run the group bys. You just have to say like, select from this table where aggregation level equals this. So this is probably a little bit confusing to y'all, but if y'all like, we're going to be working a little bit more on this stuff in the applying analytical patterns week for the analytics track. We're going to be going over a lot more of this in detail of how these aggregation levels work. But just think of it as like, what is the group by here, right? And then you could say like dim action type, put all of them here, dim action type, dim country, dim device brand, event hour. There might be like that one, right? This is like essentially like all of them together. And then you have like all the different ways that this could be grouped, right? You could think of it that way as like, because we want to do this so that when we are getting to the metric generation layer, all we got to do is select stuff for the most part. We select and divide. And then that is how we can, like, so then the metric layer doesn't have to do any heavy lifting at all. Like we do all the heavy lifting in Spark and we do it all in like the big data layer. And then we don't do anything here. So that's kind of the idea behind schemas. But what about quality checks? So we need to do quality checks on both of these tables. And let's go ahead and look at this first table here. And like usually you put the quality checks at the bottom here. So we're going to get quality checks. Again, like way too big, like 15. And then in this case, we probably want a couple here, like not null checks on dim host name, dim action type, event timestamp, dim country, yeah, logged out user ID. But device brand could be null. because of the fact that, oh, and we can probably put that in here, could be null because of bots that don't have a brand. Because like Googlebot could hit my website and it will log a record, but like the Googlebot is an iPhone, right? It's like a weird like crawler thing. So you can think about that, and then we have like make sure no duplicates on primary key, obvious one. Then there's probably a dim host name is well formatted, www.xxx.com, right? Something like that. All right. We'll put x.com to ode to Elon. Um, what else we got here? You can see how there's like a bunch more here. We can also say like row count checks, group on dim host name, and check week over week week over week counts for www.exactly.com and www.zackwilson.tech, because those are like kind of critical dimensions. Those dimensions are way bigger than the rest of them, and so you can have row count checks there. Let's see here. There's enumerate. Yep, there's one. There's a couple more. You have enumeration check on dim action type. Should be sign up, purchase, login, etc. So those ones are pretty obvious. There's going to be other ones as well that you could think of probably. So I like that for the most part. I think let's do some quality checks for the second table real quick. So like 15 quality checks. In this case, we have not null, and this is going to be on. You have dim country, dim action type. But see, one of the things that's interesting here is like if we did the not null check on the table above, do we need to do it again? Right? That's one of the things that's always interesting to me when I think about quality checks is like if you're already reading in trusted data, do we need to do these again? So in some ways you kind of don't, right? Because these are not going to catch anything. Because if they're going to be caught, they're going to be caught upstream, right? So like let's actually not put those in there because like we don't need this, right? So we've got row count checks, right? Overall rollup should have more data than any other rollup. And then probably other things on things like what are some other ones here that are going to be interesting? Event hour probably has some things, right? Event hour should look more seasonal, or should look like its old seasonal pattern, maybe something like that. Like it's like a advanced kind of check. Yeah, M total events should be greater than some minimum number, assuming that like we assume that there's going to be data every hour or something like that, right? There's like obviously there might be a time when there is no data. So then we have our quality checks. So then we have our flow, we have our flow chart, we have our table, we have our quality checks, and I think that's pretty much it. That like from like what we need to like get rolling with this pipeline.
Congrats on getting to the end of the spec building lab. I hope you're more knowledgeable about how to build good documentation because your stakeholders will greatly appreciate it over the long run. Make sure to like, comment, and subscribe, and share this with your friends if you found it interesting.